Hello students, today we are going to discuss a very important topic in physics, that is dielectrics. So I welcome you all to my new YouTube channel Physics Sketch D.N.Thatoi. So now before going to discuss all about the dielectric, let us first discuss the classification of the materials or matters. The materials are basically, we know they are classified as conductors, insulators and semiconductors. That is what I have written here. They are classified as conductors, semiconductors and insulators. Now I am here adding another word here. So insulators or dielectrics. So now basically what is conductor? That we know. Conductors are the substances which has free electron, conduction electron, and they allow the current to flow. But in semiconductor, you know, its conductivity is in between the conductor and insulator, but generally at room temperature they conduct electricity also. But the insulators blocks the current to pass through it. It has no free electrons. The substances, they will not allow the current to pass through it, they block it. Another important property of semiconductor, and due to that important property, now we are going to discuss, that is called the dielectrics. So what is that dielectric? Now the dielectric insulator means they block the current to pass through it. So that is insulator. So now we are talking about insulator. Insulator means they block the current to pass through it. If the insulator is called as dielectric, then another way we can discuss, it is the property of the material that exhibit polarizability. So when external electric field is applied, the substances they will make some dipole, and that is called the polarizability. Due to that property polarizability, then we are calling it dielectric. So basically insulators and dielectrics, they are all the same thing. So then we can also say that all dielectrics are insulators, but all insulators may not be used as dielectrics. Okay, again I am repeating. So all dielectrics are insulators, but all insulators may not be used as dielectrics. So anyway, basically dielectric means the dielectric is the property they exhibit the polarizability, and due to the polarizability that stores the electrical energy in the medium. So now let us discuss. So now again we will go to the dielectric. So dielectric are the substances that they have no free electron. And the substance of the dielectrics are these are the substances. Dielectrics are HCl, hydrochloric acid, water, sulfurous acid, ammonia, hydrogen, oxygen, carbon dioxide, methane, benzene. They all are called or the plastics, wood, paper, they are all the dielectrics. Example of dielectrics. So dielectric cannot carry electricity. They cannot carry electricity. They do not allow the current to flow it. They block the electricity, but they respond to the electric field. So how they respond to the electric field? So they inside the body, so positive charge and negative charge body will be developed, and they develop a dipole moment. Accordingly, so they are classified as dipoles are classified as polar dipole, polar dielectric, and non-polar dielectric. So another thing I am going to explain here. So if a very high potential difference will be applied in a dielectric medium, then it will also carry electricity, and that potential at which unit thickness of a dielectric will carry electricity is called breakdown voltage, or called dielectric strength of that material. So dielectric strength is, for example, the air has dielectric strength. So I am writing here the air has dielectric strength, that is equal to dielectric strength is E, that is dielectric strength, maximum electric field, strength of the electric field, breakdown voltage, that is equal to 10 to the power 6 volt per meter. That means across 1 meter, so air is present across 1 meter, it will apply a potential of 10 to the power 6, 1 megavolt. then the air will be ionized, it will also carry electricity. So before that, so it will not carry electricity, because conductor in microvolt, 1 volt, 2 volt, 10 volt, so they carry electricity. But air will carry electricity when a potential difference of 10 to the power 6 volt is applied across 1 meter. Then that is called breakdown voltage, or that is called dielectric strength of the air. Similarly for other material, 10 to the power 7, 10 to the power 8, like this. So for example, I told you, so there is no substances, it is not completely a insulator or dielectric. They may conduct electricity, but at a very high potential difference is applied on it. So anyway, next one is based on the orientation of the net charge in a dielectric molecule. Now there is a dielectric molecule. Let's say this is a dielectric molecule. So how the charges are distributed here? Because net charge of any substance is 0. Net positive charge is equal to net negative charge. But here, how the positive charge and negative charge, they are present in one point, or they are different points. Based on that orientation, the dielectrics are classified as polar and non-polar. So these are examples of polar dielectrics I have written here. Please note down. I have written these are the polar. Polar are the hydrochloric acid, water, and sulfurous or nitrous oxide, ammonia. They are polar. And non-polar is hydrogen, oxygen, carbon dioxide, methane, benzene. They are non-polar. So again I am telling why they are called polar and non-polar. Now based on the distribution of the net positive charge and negative charge of the dielectric molecule, they are classified as polar and non-polar. So okay, now let us go to the polar molecule. Okay, now we will go to the polar molecule. Okay, now we will discuss about the polar molecule. In a polar molecule, the in this case, in the polar molecule, we will find out the net positive charge and the net negative charge. They are present. They are not coinciding. They will give a particular difference between them. For example, let's say I have taken the polar molecule HCl. If we take a polar molecule HCl, then now this is the chlorine atom, and this is the hydrogen atom. This is the hydrogen atom. This is the chlorine atom. The net charge of the chlorine atom will be present here, and net charge of the hydrogen atom will be present here, because chlorine is more electric negativity. So the net charges will be here. Net charge will be here. This is equal to 1 electron. 1 electron. Here this is net charge is equal to 1 proton. So that a dipole moment is developed between the chlorine two atom. So now they exhibit a dipole moment. That is the dipole moment of the hydrochloric acid. Dipole moment. Dipole moment. Again I am telling, because the chlorine, again I am telling, this is the chlorine. The chlorine, there are 17 number of electron and 17 number of proton. Net electron, net proton, it is neutral. Net charge is equal to 0. Net charge is equal to 0. But when this chlorine is kept in contact with the hydrogen, now this is the hydrogen. So hydrogen 1 proton and hydrogen 1 electron, and it is also electrical neutral. Net charge is 0. 1 electron, 1 proton. But when they are kept close to each other, now from the hydrogen, electron will come to the chlorine side, because electron is more electronegative. So since the electron more negative, so now at the center, almost at the center, so there is a net, because this will be 17 proton, then this is the 18 number of electron. But in the hydrogen side, that is the 1 proton, and 0 electron. As a result, so this is a positive charge, this is a negative charge. In electricity, if there is a negative charge and there is a positive charge, this is the positive, this is a negative charge, this is a positive charge, then develop a dipole moment. Dipole moment is always from negative charge to positive charge. Negative charge to positive charge. Dipole moment is defined as, let's say dipole moment of each molecule is small letter p is equal to charge into distance between them. This is a polar molecule. So in case of your hydrochloric acid, in case of water, nitrous oxide, then that is methane, the ammonia, so all they are all polar. So another example I am showing here regarding the polar molecule. So this is all about the hydrochloric acid, HCl. Another water is a polar that I am saying. Let's say this is equal to water, H2O. Water is equal to H2O, that is the oxygen. Now these are the two hydrogen atoms. So now this is one hydrogen, this is another hydrogen, this is the hydrogen atom, this is hydrogen atom, this is the oxygen. So this is the negative charge and this is will be positive charge. So they develop a dipole moment in this direction. This is another negative charge according to bond. Negative charge, this is the positive charge. So again they will develop a dipole moment. So net dipole moment will be in this direction. That means, so at this point there is a net negative charge. And this is a positive charge, this is a positive charge. The center of these two positive charge will be here. So now this is the net negative charge. This is the center of the net positive charge, net negative charge. So they will develop a dipole. So in this case, this is a water molecule also develop a dipole. This is a polar molecule. So the order of dipole moment of hydrochloric acid is, it is around 1.08 dBi. So unit of dipole moment is dBi, DEBYE. That is equal to 1 dBi. That is DEBYE. 1 dBi is equal to 10 to the power minus 18 start coulomb centimeter. Start coulomb into centimeter, and that is the 1 dBi is 10 to the power minus 18 start coulomb centimeter. Now again you remember 1 dBi is equal to, this is equal to around 3.33. That is 3.33. That is your coulomb meter. That is 3.33 into 10 to the power minus 30. 3.33 into 10 to the power minus 30 coulomb into meter. That is the value of the 1 dBi. So 1 dBi is equal to 10 to the power minus 18 start coulomb centimeter. So this is the CGS unit of dipole. And in SI value you will convert, it will be 3.33 into 10 to the power minus 30 coulomb meter. So all the dipoles, the molecular dipole moment value is in the order of 10 to the power minus 30 coulomb meter. So again remember one thing, what is 1 dBi? Please remember. This is all about the polar dielectric. So another thing I will tell, from the polar dipole they have a permanent dipole moment, because I told you hydrochloric acid, it has permanent dipole moment. Water molecule, it has a permanent dipole from the birth. When the water molecule is developed, so it is prepared. So now that molecule has some dipole, because net positive charge and a net negative charge, they will not coincide. There is a gap. Due to the gap, it is a dipole moment. Similarly, water molecule, hydrochloric molecule, nitrous oxide, they have some permanent dipole moment in polar dipoles. So another thing is I will say, so let us take some polar molecules in a container. Let's say it is a region where all the polar molecules are present. So you know polar molecule, one polar molecule give a net dipole moment. This is the net dipole moment is this. One molecule. Let's say this is water molecule. So it is from dipole moment, because it is polar means it is a molecule having permanent dipole moment this much. Now in this domain, all the dipoles I will be showing here. They are showing the dipole moment in a disordered manner, so that if you will add the all dipole moments, now you will find out net dipole moment of this system is equal to 0. So this is dipole moment here. This dipole moment is in this direction. This dipole moment is in this direction. This is here in this direction. This is in this direction. This is in this direction. So if you add the dipole moment of all individual small p, dipole moment of all individual dipoles, then summation I is equal to 1 to n. Let's say n number of molecules are there in this phase. So which molecule? That is the polar dipoles. Polar molecules. So polar molecule. So now net summation is equal to 0. So they exhibit 0 dipole moment. So why they are disorder? Because of the thermal agitation, thermal energy. So next one is when external electric field is applied to this polar dipoles. When external field is applied to the polar dipole, what will happen? Look here. When external field will be applied to the dipole, so you will find out. So now they will be aligned. They may not be horizontal. Let the external electric field is here. This is the external electric field. This is the external electric field. It will not be aligned exactly along the external electric field, but they try to align. So like this, they try to align like this, so that there will be a net electric field. So like this. Look at clearly. So almost all are showing towards right. Almost towards right, not exactly parallel to right, but inclined somewhat. But here, somebody is right, somebody is left, somebody is downward, somebody is upward. That's it. Net is 0. But in this case, when an external electric field is applied, they all tries to be aligned along this direction, and the summation of each molecule contribution dipole moment vector is not 0. So that is I is equal to 1 to n. Now another important property you can observe here. The net dipole moment of all the molecules of the polar dielectric will increase if the external electric field will increase. Again, if electric field strength will increase, they try to align more and more. So finally they will be all horizontal, parallel to the electric field. But they are not parallel, they make some angle. So they make some angle, this one theta. But when the external electric field will be strong, then all will be aligned. Then net dipole moment value will be increasing. But another thing is that if temperature is more, again they try to be more disorder. So to make a good net dipole moment, to make a huge dipole moment, it should be at high electric field and low temperature. At low temperature and high electric field, polar molecules will behave as a good dipole or polar value. So now it is all about the polar dipoles. Let us come to the non-polar dipoles. Non-polar dielectrics. That is the non-polar dielectrics, and this is all about, I was talking about polar dielectrics. Polar dielectric means they have permanent dipole moment, and when electric field strength will be increased, the net effect of the dipole moment will increase, and temperature is more, again this net value will decrease. If temperature will be less, it is better to trend them, to align them, so that net electric field will be, net dipole moment value will be more, net dipole moment. Next come to the polar, and now I am going to non-polar dielectric. Non-polar dielectric. Then I told you non-polar dielectric for, let's say, hydrogen or oxygen, they are the non-polar dielectrics molecules. Non-polar means the centroid of the net positive charge and the centroid of net negative charge will coincide. Let's say, for example, hydrogen. Now this is the hydrogen atom. This is hydrogen atom. At the center the positive charge is present. This is center where positive charge is present. That is equal to 1 proton. At the center 1 proton. And this is the cloud of electron. Where electron moves, this is the probability of getting the electron. This is called electron cloud. This is called electron cloud. The electron is a negative charge. The centroid of the electron cloud is also here. This is the 1 and positive. This is 1 negative. So the total positive charge and the total negative charge, they coincide at this point for the hydrogen atom. So net dipole moment is 0. For a non-polar, the word itself indicating the no polar, it is developed. The no polar developed means positive charge, negative charge is at one place. Centroid of positive charge and centroid of negative charge, they will be at one point, no dipole moment. So if you take another atom of hydrogen. Now this one is also positive negative coincide here. Then it becomes, this is one hydrogen, this is another hydrogen. Then develop a hydrogen molecule. So this hydrogen molecule is becomes non-polar because this is positive negative. This is also positive negative coincide. So net dipole moment of the substance is 0. This is all about the non-polar dielectric. Example, I told you oxygen, hydrogen. Sometimes carbon dioxide is also a non-polar dielectric. How? Look here, carbon dioxide. So I am giving a, this is the, let's say this is the carbon. This is the carbon atom. This is the carbon atom. This is the oxygen atom. This is another oxygen atom. So now this polarity will be, this is negative, this will be positive, this will be negative, this will be positive. So it is a dipole moment towards the center, it is a dipole moment towards the center. Both the dipole moments are same. Net dipole moment is summation of net dipole moment of this carbon dioxide molecule is equal to also 0. Net dipole moment of the carbon dioxide molecule P, one molecule, net dipole moment of this molecule is equal to 0. So carbon dioxide is a linear. So though it has dipole moment, but the net dipole moment is equal to 0. But hydrogen, so it is dipole moment 0. This is also dipole moment 0. But in carbon dioxide, there is a dipole moment, but the resultant dipole moment of the two bonds is equal to 0. So this is also coming under which category? Non-polar dipole moment. So again here, so when a non-polar substance is placed in an external field, so the net dipole moment will increase. Now look at here. Let us look at here. The way I have told you polar, then similarly let us discuss about the non-polar. Now this is the substance. No external electric field. Here external electric field is not there. External electric field is not there. So obviously all the atoms, this is positive, this is negative, they are moving randomly here and there. So this is the positive, here negative. This is center of positive negative, center of positive negative, center of positive negative, center of positive negative, center of positive negative. So this is the state of a non-polar dielectric in the absence of electric field. So when they are placed in a presence of electric field, now electric field is present, electric field is applied, external is applied, then they will develop some polarity. So now they will be like this. They will be slightly elongated like this, so that it will be all. So initially 0 0, but initially it will be positive. So when electric field is going to right, means it will be negative positive, negative positive, negative positive, negative positive. So dipole moment is now developed, negative positive, negative positive, negative positive. So individual dipole moment increases. So the summation of dipole moment of each molecule. So how many molecules are there? From I is equal to 1 to n. Independent molecule is 0? No, it is not 0. So it is net dipole moment is not 0. So they exhibit net dipole moment is this. So the net dipole moment of this domain will increase if external electric field will increase, and it is independent of temperature. Very important. So for a polar, it is depends on temperature. For non-polar, it is independent of temperature. Temperature may be more, temperature may be less. It is independent temperature. But external electric field is applied. More external electric field, net dipole moment of the system will be more. Why it is more? Why it is more? Because when external electric field will be more, this dipole will be elongated more. So it will be negative positive. If the distance will increase, you know dipole moment is the product of charge in the distance between the two poles. When external electric field will be more, it will be elongated more. So external net dipole moment will be more. This is the how the net dipole moment will be more here. This is how I have explained for a non-polar. And in that case, how the electric field will be more, that also I have developed in that case. So now we will discuss when a non-polar molecule or atom is placed in an external electric field, so how much dipole moment it will be getting or receiving or adopting or induced, that value we are going to solve, or we are to derive, or we will make a model and we will find out what is the atomic dipole moment of a non-polar dielectric. So one model I am showing here. Please Everybody very carefully listen here. So look, so this is a molecule. This is a molecule non-polar. I am now discussing about the non-polar. Please keep in mind, I am discussing about a non-polar dielectric. Non-polar dielectric. Non-polar dielectric. Now this is dipole here. This is the positive charge, net positive charge, and here also net negative charge coincide. But net positive charge is present at the center, and the net negative charge is in this presence of a cloud. You know, there is an electronic cloud, so the probability of getting the negative charge in this region is there. Okay, the probability is same everywhere. So now this is the positive charge is the present, and negative charge, the centroid of the negative charge also at the center, but negative charge distributed throughout the body. When external electric field will be applied, what will happen? Now this is the electronic cloud. This is called electronic cloud. This is called the electronic cloud. So where the electron is randomly moving here and there. If the electron is moving here and there, so centroid of the electron is here. Now the centroid of positive charge was here, but I am now applying some external electric field. This is very important term I am going to derive. Please listen carefully. External electric field is applied. So external electric field is going to right means you know electric field is always going from positive charge to negative charge. Maybe there is a positive charge, maybe there is a negative charge. Electric field is always that external electric field is applied always from positive charge to negative charge. So the effect of the external electric field, what will happen? Now this positive charge, this nucleus, because in the center there is a positive charge, at the center there is a negative charge. So the positive charge will be displaced to right and negative charge will be displaced to left. So that electron cloud is here and the positive charge is separated. So now please carefully understand here. Now this is the positive charge, positive charge. Now this is the center of the negative charge. So now they are replaced by a distance r. Now they develop a molecular dipole moment of each molecule. Dipole moment, molecule or molecular dipole moment is a vector. It is equal to product of the charge and the distance between them. Why a distance is developed? Because of the external electric field applied. When the external electric field is applied, that electric field will pull the positive charge along the external electric field and pull the negative cloud toward the negative. One thing I am keeping in mind, or I am assuming that let the electronic cloud almost remains spherical. That is the assumption I have taken. So to make a model of dipole moment. Then come to the point here. Now come to the point here. What do we know? Now we know always that if there is a charge sphere, spherical charge where charges are distributed uniformly, in a body, let the charge distribution is rho. Then from the center at a distance r, what is the electric field? Now electric field at a distance r from the center of a spherical body is electric field is equal to rho r by 3 epsilon 0. That we also know from the Gauss law. From the Gauss law, if there is a sphere, charges are distributed uniformly throughout the body, then the electric field at a distance r from the center is rho r by 3 epsilon 0, where rho is the charge per unit volume, charge per unit coulomb. So that concept now we are going to apply here. Then what is the apply here? Now this is the electronic cloud, negative charge. Now now at a distance r from this, what is the electric field? So here, so electric field will be in which direction? Since it is a electronic cloud is negative, so here the electric field developed at this point is equal to towards left. Electric field is towards left. So now this is the electric field left. This is the electric field E due to the electronic cloud. And external electric field is to right E expand. So what is that electric field due to electronic cloud? Now come to the point. This part, please carefully with concentration. Listen that E is how much? Now E is equal to, according to the formula, electric field here due to the electronic cloud charge is equal to rho r by 3 epsilon 0. What is rho? Now rho is the charge density. So what is the charge of the negative charge? Total negative charge is Q. At what volume it is distributed? Let the radius of the sphere is electronic cloud radius is R. So rho is equal to Q by 4 by 3 pi RQ. That is the charge, negative charge. So I am not writing negative, but I know this is negative charge. So this electric field developed due to the electron cloud at a distance R from the center of the sphere is charged by, this is the density into R divided by 3 epsilon 0. So that electric field is how much? 3 cancelled out. Then it is coming to be how much? That is equal to Q into R divided by 4 pi RQ epsilon 0. This is the electric field. And again you can write also that electric QR. Who is QR? QR is the dipole moment of this dipole. So that is equal to dipole moment. Small letter P divided by 4 pi RQ epsilon 0. That is what dipole electric field developed. So again come to the important statement. This part I am using. The important statement is, so this charge, this positive charge is pulled by the external electric field in this direction. A negative charge at the center will pull it toward the center. So now make the diagram here. This is the positive charge. This positive charge is plus Q. It is pulled to direction by which electric field? External electric field into Q. So this charge will be pulled toward the center, because it is center, the net negative charge is present, it will pull to left. That is equal to electric field due to the electronic cloud into Q. So when this one and this one will be equal, then this positive charge will be in equilibrium and they develop a induced dipole moment. So that induced dipole moment model I have discussed here, that is now in this equilibrium, then I can say that E external into Q is equal to induced electric field, that is electric field into Q, that Q cancelled out, so that is E external is equal to E. Now in this case apply E external is equal to U. Now you write down that is equal to E external electric field is equal to the electric field developed at this point due to the electronic cloud are same. Now that E already we have developed this one, that is equal to P, small letter P please mind, I am just pointing always, that is RQ into epsilon 0 into external electric field. So the dipole moment of this molecule, one molecule, is how much? 4 pi epsilon 0 RQ into external electric field. This is the important derivation. This is the induced dipole moment of a non-polar dielectric in the presence of external electric field. Again, this is the induced dipole moment, not permanent. For a polar molecule, there is permanent dipole moment. For a non-polar dielectric, there is induced dipole moment of one molecule due to in the presence of external electric field, and that value is equal to 4 pi epsilon 0 RQ E external EXT, that means external electric field. Now this part I am using. So now in this case I can say the dipole moment by the one molecule is equal to how much? That is equal to, that is, I can write like this, that is equal to some epsilon 0, some constant Ls alpha, and this is the external electric field. So here the term alpha I am writing. So this equation is the same equation. So alpha may be written all the things. Now alpha is equal to P mole by this is called molecular or atomic polarizability. That is your atomic polarizability. Atomic polarizability. So alpha is the substitute of which term? Alpha is the substitute of approximately substitute of this one, and this one. So unit of alpha is equal to meter cube. So please remember the unit of atomic polarizability is equal to meter cube. So this is a very important statement. Please remember. So again I am writing here that atomic polarizability or the induced dipole moment of one molecule is a vector quantity, molecule not mole, molecule is equal to how much? Epsilon 0 alpha into E external electric field. Alpha is the atomic polarizability. This is all about the model how an induced electric field is developed inside the non-polar dielectric. Okay. After getting all information all about this, now let us go to classify what is the difference between polar dipole and non-polar dipole. This is a brief description of polar dipole. Again, so now finally I am going to conclude what is the polar and what is the non-polar dipole moment. Let us conclude this one. Very interesting. So that if somebody will ask you what is a dielectric, so you say insulator. Yes, insulator. But the insulator word is frequently used for it is conducting electricity or not, then it is called insulator. If I will say dielectric, then that part I am not discussing. I am discussing whether the medium, what is the medium is doing when external electric field is applied. So when external electric field is applied, it is polarized. So it shows the property atomic polarizability, and due to that property, it stores electrical energy. That's why insulators are also called dielectrics. So same thing. Then again also I told you all dielectrics are insulators, but all insulators cannot be or may not be used as dielectrics. Now let us come to a differentiation between the polar and non-polar. Write down. Polar and non-polar. This is the polar. This is your polar dielectric. This is your non-polar dielectric. Both are dielectric, but polar dielectric means it has no permanent dipole moment, but non-polar they have no dipole, but they will exhibit or they will induce dipole moment. One is they have permanent dipole moment. They have permanent dipole moment. The example I showed you, hydrochloric acid, water, they have permanent dipole moment, but non-polar they have induced dipole moment. They have induced dipole moment. This is important. They have a permanent, they have induced. That is non-polar. So when external electric field is applied, then it will be induced. Then come to second point. Second point is this polar dipole moment. The strength of the dipole moment depends on temperature, and it is independent of temperature. It is a very important part. It depends upon the temperature and independent of the temperature. So you write, so net dipole moment depends on both external electric field and temperature, but a non-polar depends on only electric field, depends on only external electric field. It is independent of temperature. External electric field, it is independent of temperature, but depends upon both external electric field and electric field. So another point is, by increasing the external electric field, when the external electric field will be increased, net dipole moment increases. So when the external electric field is increased, net dipole moment increases. So now I can write, so here net dipole moment will increase when external electric field is increased. How? Now in this case, so let the dipole moment dipole is here. So now when external electric field is applied, so it will be aligned more. The angle between this angle will decrease. It will be aligned more, external electric field more. Again it will be like this. So that means when external electric field is more and more, so So the dipole will be aligned toward the net electric field and net dipole moment increases. But here in non-polar, when the external electric field will be applied more, then what will happen? The polarity will increase. So negative charge and positive charge, this distance will increase and the dipole moment will increase. That is the important part. So here in polar, when external electric field will be more, net dipole moment of the system will increase. Why? Because dipole will be inclined like this. Gradually it will be showing this way and parallel to the external electric field. So net electric field dipole moment increases. But here, so from the beginning it is along this direction. But only thing that the gap between the positive pole and negative pole will increase and net dipole moment increases for a non-polar. And it depends on temperature. How depends on temperature? When temperature is less, dipole moment is more. Net dipole moment is more. When temperature is more chaos, then net dipole moment will decrease. So at a low temperature, high electric field, net dipole moment will increase. Another last point, important point is polar dielectrics is developed due to two atoms having different electronegativity. Let's say HCl. So it is more electronegative than hydrogen. But in hydrogen and hydrogen, so they are of same electronegativity. Since they have same electronegativity, so center of mass of centroid of positive negative will coincide, center of positive negative will coincide. That's why they are non-polar. But in case of a polar, the chlorine is more negative. That's why it will attract the electron of the hydrogen towards it. So there will be a polar. One side will be more positive, another side will be more negative. That is case of a polar and this case of a non-polar. But another cases also there. Let's say carbon dioxide. It is also a more, this is more negative, this is more positive. That is negativity. But they will develop a dipole moment, but net dipole moment of the system becomes 0. So these are the very important aspects of polar, non-polar, dielectric. What is a dielectric? So dielectric means insulator. The insulator character is divided by two parts, either insulation, block the electricity, or it will be energized, it will store energy because of the polarizability. This is all about the dielectric introduction class. In the next class, we will discuss some other phenomena in dielectric. This is all about. Thank you. So if you like my video, please subscribe and share. Thank you all.